Imagine a colossal gathering played by an unending number of stars, planets, and moons, all playing together superbly. In any case, there is one explicit fragment of this orchestra that has surprised space specialists for a seriously prolonged stretch of time: exoplanets. Exoplanets are standard planets that exist outside our planetary system, hid away someplace down in the Milky Way. You might be astonished to find that, among the colossal number of cosmic objects, there are exoplanets so like Earth, so tantalizingly comparable yet puzzling, that they might be our planet's heavenly twin. We jump into the interesting area of Proxima b, found just 4.2 light-years away. The James Webb Space Telescope is disturbing our journey for a comprehension of these divine secrets. Imagine a second when your mind adventures across the enormous astronomical area of our reality, the Milky Way, which is home to more than a quadrillion exoplanets. That is a number with 15 zeros. To place this number in context, if each of these exoplanets were the size of a grain of sand, we wouldn't simply fill the Grand Canyon, but we would have to the point of making another land milestone on Earth, a Grand Canyon 2.0 that would extend for a huge distance. It's generally surprising that around 20% of these grand bodies have been assigned Earth-like as far as geography and air structure. That means there is a 1 in 5 chance of finding a twin of our planet. And the story doesn't end there. Close by these planets, there could be another quadrillion moons, rough satellites like our moon, trapped in gravitational hit the dance floor with their parent planets. If you somehow manage to contemplate tracking down another body in space that harbors life or could do so, the universe offers a flood of chances. Now that we have spread out the material of admirable scale, it's time to introduce the master skilled worker prepared to paint its complex nuances, the James Webb Space Telescope. This heavenly Sherlock Holmes, with its amplified central focal point displaced by flexible central focuses, beats even the most advanced optical instruments. We're not discussing any focal point. It's 6.5 meters in essential mirrors, 2.7 times greater than Hubble's. Imagine the best detail it can separate, even in the smallest glimmer of a star billions of light-years away, and then at that, inspect the nuances of revolving around planets. What makes the James Webb Telescope revolutionary isn't simply its seeing power, but also its high-level technology, including advanced sensors and spectrographs. These devices can do significantly more than simply notice. They can investigate and channel the unprecedented light checks sent or reflected by grand objects to decipher their air conditions, harmony, density, and, surprisingly, mass. Going about as a space researcher, they can decide whether a planet has water, organic mixtures, or even oxygen. The James Webb Space Telescope has the ability to answer these inquiries, raising it from a simple observer to a logical virtuoso. It's not just an advance over its ancestor Hubble, it's more like a quantum jump. In the event that Hubble's disclosures flabbergasted you, plan for a genuine occasion of radiant divulgences. Just as we extended our look across the complicated scene of the universe, it's worth zeroing in on one explicit star in the divine show, Proxima b. Since its discovery in 2016, this perplexing planet has stuck out as a Shakespearean legend, loaded up with multifaceted design and problems, stunning stargazers and anthropologists alike. What's the deal with all the quarrel? First of all, Proxima b is basically in our galactic area, just 4.2 light-years from Earth. To put it in context, on the off chance that you could beat the universal speed limit and go at the speed of light, you would show up in somewhat more than 4 years, about the same amount of time it takes for your favorite program to fall into reruns. But let's dive further into why this nearness is so significant. We're examining a universe that broadens in excess of 93 billion light-years from one end to another. So finding a planet so close and thus uplifting for logical exploration is like viewing as a gem in a heap the size of Mount Everest. A gem that possibly holds mysteries about existence itself. In the grand embroidery of the universe, Proxima b is a complex line, offering us significant pieces of information that could rethink how we comprehend tenability and life beyond Earth. It's not simply Proxima b's nearness to Earth that excites established specialists, but also the captivating signs that this planet isn't just Earth-like, but potentially Earth 2.0. Proxima b sits serenely in what space specialists call the habitable zone of its parent star, where conditions are neither too hot nor excessively cold, but just right for liquid water to exist. Imagine cascades, meandering streams, massive lakes, and perhaps oceans as deep and puzzling as the Mariana Trench. However, before we begin dreaming about going on Proxima b, we should think about a couple of its characteristics. Leading a solitary day on this intriguing exoplanet endures a faltering 11 days. Imagine daybreaks that not just introduce another day but unfurl slowly, opposing giving way to afternoon, and sunsets that wait, making brilliant hours that photographers long for. While it sounds idyllic, it also has huge implications for its climate and livability. How should human biorhythms change in accordance with the patterns of light and dark on Proxima b? Would we really need to eat 3 or 4 times as much in a single day on that planet? Would we sleep the same way on this very surprising world? The fundamental patterns of life, as far as we know them, would be both tantalizingly similar and frustratingly peculiar. It's as though nature is giving us a riddle wrapped in a riddle, testing our understanding of what makes a planet habitable. You could consider how we can gather precise and solid information about a world we've never visited. The James Webb Space Telescope delivers all its capacities like a giant Swiss Army knife. It's more than just a telescope. It's an incredible research lab in the vacuum of space. Thanks to its innovative technology, cosmologists not only notice planets, but also examine them through a prism of scientific instruments that would make CSI labs look simple. Using advanced spectrographs, the Webb telescope can analyze the light produced and reflected by these far-off planets. Each element or compound in a planet's atmosphere absorbs or produces light at a specific frequency. By focusing on these patterns, researchers can perform a distant biopsy of divine bodies, determining not only atmospheric pressure and density, but also the possible presence of compounds fundamental for life, like water, organic carbon molecules, and even oxygen. Space science is not just cosmology, it's space criminal science. We don't sit idly by, waiting for clues to come to us. We actively search for them, exploring the molecules and atoms that make up these perplexing universes. The Webb telescope isn't just an eye in the sky. It's a highly specialized research lab, specialist, and vast analyst all in one. It allows us to turn our hypotheses and theories about alien worlds into strategies to confirm or deny them, changing our understanding of what could exist beyond our blue dot. Right when you thought you had uncovered the most stunning layers of this galactic onion, the story veers off in a strange direction, much like in any science fiction thriller. Researchers using the James Webb Space Telescope caught something surprising from Proxima b, a signal so astounding that it spread all through the academic halls and social media. Named as a potential technosignature, it was an electromagnetic emission so perplexing and complicatedly designed that it could point to the presence of an advanced civilization. The collective heartbeat of humanity seemed to stop at the pinnacle of a discovery that vowed to reshape our perspective on reality. Could the signal be the historical confirmation that we are not alone in the universe? And just as quickly as it appeared, the signal disappeared without repeating, leaving behind not just a staggering silence, but also a maze of unanswered questions and foaming speculations. Was it simply a transient celestial oddity, a fortuitous event of cosmic arrangement, or something else deliberate, a coded message, or even a sign of extraterrestrial intelligence? The solitary mission cast a shadow of mystery over Proxima b, igniting fierce debate and theory. Was it merely a passing anomaly, or is it part of a much larger story, more complex than we can imagine? But wait, the account of our grand investigation is unfinished. The ink has not yet dried, and new chapters are still being written. This time, it's not just ordinary researchers but Harvard scientists who are leading a change in perspective. As we continue our search for extraterrestrial life, they are not satisfied with just exploring the signals and anomalies we've talked about so far. They are upping the ante by turning the James Webb Space Telescope into a sort of giant night vision telescope. They intend to search for artificial light sources in both the dark and illuminated areas of distant worlds. We're looking at staggering possibilities, such as the chance of detecting artificial versions of cities glowing in the dark, like brilliant SPS. Imagine seeing the gleaming light emissions. Could be a city, humming with the presence of an advanced human civilization, emanating its glow into the immense, vast oceans. As we continue to unwind the mysteries of the universe, the venture for extraterrestrial life takes on new aspects. Beyond the immediate interest in Proxima b, our fantastic hunt digs deeper into the massive new regions of space. This pursuit is driven by both technological advancements and a profound curiosity about our place in the universe. Continuous leaps forward in cosmology and space exploration have led to the discovery of various exoplanets with potential habitability. Instruments like the James Webb Space Telescope, biosignatures, and ground-based observatories have expanded our ability to identify and study these distant worlds. One especially captivating area of study is the search for biosignatures, signs of life. These signs could include atmospheric gases like methane or carbon dioxide, which under the right circumstances could suggest biological processes. The JWST's capabilities extend beyond basic detection. Its advanced instruments can measure the atmospheric composition of exoplanets with astounding accuracy. By studying starlight that filters through an exoplanet's atmosphere, scientists can identify chemical markers indicative of life. For example, the presence of water vapor alongside other key molecules, such as oxygen or ozone, could highlight the potential for life-sustaining conditions. Another avenue of research involves studying the conditions of these distant worlds. Environmental models based on data from the JWST can help predict whether an exoplanet's conditions might support liquid water. This is critical because water is considered a key element for life as we know it. Scientists are especially interested in planets located in the habitable zone of their parent stars, where temperatures could allow stable liquid water. The search also extends to the moons of exoplanets. Some of these moons, particularly those in the habitable zones of their host planets, could have conditions conducive to life. For example, icy moons in our own solar system, like Europa and Enceladus, are thought to harbor subsurface seas beneath their frozen crusts. Similarly, moons orbiting exoplanets could present conditions where life might exist. In addition, the concept of technosignatures has gained some momentum. These are indications of advanced human civilizations that might be detectable through artificial structures or technologies. This could include megastructures like Dyson spheres, theoretical constructs designed to capture a star's energy, or unusual patterns in radio transmissions. As we refine our global collaborations and observational methods, the search for technosignatures could uncover the presence of extraterrestrial intelligence. In addition to technological advances, global cooperation plays a crucial role in the search for extraterrestrial life. Collaborations between space agencies, research institutions, and private companies enhance our ability to explore space. Model missions to Mars and other celestial bodies involve contributions from various countries, pooling resources and expertise to achieve shared goals. Public engagement and education are also critical aspects of this mission. The excitement surrounding space exploration motivates the next generation of scientists and engineers. Effort programs and educational initiatives help foster an interest in STEM fields and encourage young people to pursue careers in space science. The development of new technologies also contributes to our understanding of the universe. Advances in telescope design, data processing, and computational models improve our ability to detect and study distant exoplanets. For instance, cutting-edge space telescopes like the planned Extremely Large Telescope, ELT, and the Habitable Exoplanet Observatory HABEX are set to provide even more detailed views and deeper insights into the potential habitability of exoplanets. As we push the boundaries of our knowledge, each new discovery raises new questions and areas for investigation. The search for extraterrestrial life is not just about finding alien civilizations, but also about understanding the origins and potential diversity of life in the universe. It challenges our knowledge and expands how we might interpret what it means to be alive. In conclusion, the exploration of exoplanets and the search for extraterrestrial life are dynamic and evolving fields. With each advancement, we edge closer to answering some of the most significant questions humanity has ever asked. As we continue to explore the universe, the opportunities for finding new forms of life and understanding our place in the cosmos remain boundless.